Okay, so we're going to do a video on an application of Bayes' theorem, pretty straightforward application. Um, just as a quick reminder, Bayes' theorem is this really nifty thing that involves the law of total probability. Law of total probability isn't Bayes' theorem, but it's a part of Bayes' theorem. Probability. Hopefully that's all legible. So think about this. So say we have some events. Something like B1, B2, ... B, let's go with BK. And say they are disjoint, right? That means they're mutually independent, and exhaustive, right? On some space, right? In some space, they're mutually exclusive and exhaustive, right? So that means that on this space, you know, this space is completely covered by the union of all of these B's. So what that means is that anything else that occurs in this set can be described by its relationship with these B's, right? Because they're mutually exclusive and exhaustive. So if we have some event A, then the probability of that event A is simply equal to the probability of A and B1, right? Plus the probability of A and B2, right? Plus the probability of A and BK, right? Because the sum of all of these things is the sum of all the different ways that A could occur, and we know that they're all disjoint, right? We know they're all disjoint, and we know that they're exhaustive. So now it's possible that some of these are zero, right? It's possible that A and BK never occurs, right? But that's okay. That's not going to mess with our sum. So if we sum up all of these intersections of A and B's, right, in the set, then we can get nothing else other than the probability of A, right? Because that's just the sum of all the different ways that A could happen, right? So we can write this in summation notation. Right. And if we remember our laws of conditional probability, then we can write this thing like this. Right. And I haven't changed anything there. So this is essentially the law of total probability. And Bayes' theorem takes this and just goes one step further. Bayes' theorem says, okay, I can use this thing to say, if I want to know the probability of some BI given A, well then, that's simply the probability of BI and A divided by the probability of A, right? Which is, as we've just shown, the same thing as that sum. Right? So it's kind of straightforward once you spend enough time looking at it, but it's really neat. Essentially, what we're saying is that I can use information about B and a little bit of information about A to figure out what the probability of some b I is given that A. So let me show you an example. And this is a very straightforward one, but Bayes' theorem has a lot of powerful examples. So say we have some machines. Is everything still in focus? Yeah. Let's say we have some machines. 1, 2, and 3, right? So we have 3 machines. Let's say that they all make springs, or I think that was the example that I originally got this problem from. Let's say that they make some part, right? We'll say that it's springs, and say that they're all the same length. Let's say that the probability that a given spring is defective right? So let's say the probability that the probability of defective, right, of something breaking, given that the spring was produced by machine 1, right? So this is the probability that we get a defective spring knowing that it came from machine 1 is equal to, let's say, 0.02, right? Let's say the probability of getting some defective spring, given that we know it came from machine 2, is equal to 0.01, right? And the probability of getting some defective spring, given that it came from machine 3, is equal to 0.03. Okay. So, let's say we have this information, but let's say that what we really want to know is what is the probability of picking a bad spring. Okay, so let's start there. So, well, the probability that we get a defective spring, right, must be the sum of all the different ways that we could get a defective spring, right? So that's simply equal to the probability that we get a defective spring and it came from, right, and it came from I, right, which is just this, right? This is the same thing as the probability that we got a defective spring and I, right, and it came from 1, right, plus the probability of a defective spring and it came from 2, right, which we know is just this quantity, right? Sorry, that's a 2, plus, I'm gonna clean this up. I realized that sometimes my handwriting is not so crisp, so fresh and so clean. So the probability of defective given 2, right, times the probability of 2, plus the probability of defective and 3, and I've run out of room here, but times the probability of 3. I'm going to say that out loud because there's no way you're going to be able to read that. That's times the probability of 3. Okay, so all we need to know then is the probability of these things, right? Because we already have the probability of these things, right? So